record. So we're continuing on with our Chem 107 exam review. So when we last left off, we were analyzing isotope notation for phosphorus, 33. So again, we're asked to figure out the number of protons, neutrons, and electrons. So first and foremost, we know, looking at phosphorus, that it has an atomic number of 15. So then we know immediately that our number of protons is 15. Our number of neutrons is equal to the mass number minus the number of protons, which is equal to 33 minus 15, which gives us 18 neutrons. Does this make sense to everyone so far? Is everyone following so far?
Yes.
Perfect. Okay, so now to calculate the number of electrons, we take the number of protons minus the charge, which in this case gives us 15 minus 0, so we have 15 electrons. So we'd have 15 protons, 18 neutrons, and 15 electrons. Does this example make sense to everyone?
Yes.
Perfect. So I'll clear and let's now discuss the next example in the sequence. So in this case, we're looking at tellurium. Would someone like to look at the periodic table and tell me what
52.
52? Perfect.
Yeah.
So the atomic number of tellurium is 52. So we know our number of protons is 52. Our number of neutrons in this case is our mass number, which is 122, minus the number of protons, which is 52. And that gives us 70 neutrons. For our number of electrons, we take our number of protons, which is 52, minus the charge, which is -2, and that gives us 54 electrons to work with. Does this make sense to everyone?
Yes.
Any questions on this example? So we have 52 protons, 70 neutrons, and 54 electrons. Any questions that I can address? And if you have any questions, don't be shy to ask them verbally or in the chat. So let's clear now and move on to the next example. So in this case, we're asked to fill in the blanks for our symbol. So in this case, we're asked to write an isotope symbol with each of the numbers. So in this case, we know we have 41 protons. So we're going to put our atomic number in the bottom left. We know that we have 47 neutrons. So then we can figure out our mass number, which is equal to the number of protons plus the number of neutrons. So 41 plus 47 gives us 88. So we fill in our mass number and atomic number. What element symbol, what element has an atomic number of 41?
Niobium.
What was that? Niobium? Yep, exactly right. So we put the symbol for niobium. Okay, and now to figure out the number, to figure out the charge, which is, let's undo that. So to figure out the charge, what we're going to do is we're going to take, for our charge, we take the number of protons minus the number of electrons. So we have 41 minus 38, and that gives us a charge of +3. So we've written out the symbol and isotope notation for the following ion. Does this example make sense to everyone?
Is it okay to write a 3+?
Yes, that's more than okay.
Okay.
Any other questions on this example? If not, let's keep going then. So for 23, we're asked to fill in the blanks. This time we have lead 2+. So looking at lead in the periodic table, what is the atomic number of lead?
82.
Yep, exactly right. So we know for our number of protons, we have 82. For our number of neutrons, we take our mass number, which in this case is 206, minus the number of protons, which is 82, and that gives us 124 neutrons. Finally, our number of electrons is equal to the number of protons minus the charge. In other words, the number of electrons is equal to 32 minus the charge, which is 82 minus the charge, which is plus 2, and that gives us 80 electrons. Does this make sense to everyone?
Yes.
Perfect. So let's look at the next example in this series. So in question 24, we're asked to fill in the blanks and symbol for the 5th row of the following table. And in this case, we're asked to assume that this is an ion with a +2 charge. Okay. So then we can solve for the number of protons by taking the number of electrons minus the charge, which in this case